Hi everyone, welcome to Numeric Learning. So, in today's video, as a part of Do Math with me, I would like you to take your notebook and pen and solve questions with me. I will read the question. If you can pause the video and try it yourself. The first question for today is, what is the greatest possible speed at which a girl can walk 95 meters and 171 meters in an exact number of minutes? Now what is asked? What is the greatest possible speed? What can be the maximum speed at which a girl can walk a distance of 95 meters and 171 meters in an exact equal number of minutes? So, the greatest possible speed cannot be a number greater than the given number, right? It is definitely going to be lesser than. So, if it is less, if the required answer is going to be lesser than the given data, okay, so if the required answer that you are being asked is less than your given data, then you will be calculating your HCF. You will be calculating the HCF. It's the HCF which will give you the greatest possible speed. HCF of the two values that are given are 95 and 171. So let's go ahead, do the prime factorization of 95. Start with 5. So 5 ones are 5, 45, 5 nines are 45. Okay, so 19 is a prime number. And then moving on to the next number, which is 171. Start with 3. So 3 5s are 15, 21 3 7s are 21. Again go with 3. So 3 1s are 3, 3 9s are 27, and 19 is a prime number. So the prime factorization of 95 is 5 multiplied by 19. Okay, and for 171 it is 3 square multiplied by 19. So what I am going to do is I am going to make the factors equal. So here in 95 you have 5 and 19. You don't have a 3 here. So I am going to write multiplied by 3 to the power 0, and here we don't have 5 as a prime factor. So we will make it common. So across the two numbers we have 3, 5 and 19. 3, 5 and 19. So it's easier for us to calculate the HCF. So for HCF you will be taking the lowest power of the lowest power of each of the common prime factor. So for 3, what is the lowest power? 3 to the power 0. For 5, what is the lowest power? Look at the powers of 5 here. This is 5 to the power 1, this is 5 to the power 0. So the lowest power is 5 to the power 0. And for 19, it is 19. So the answer is going to be 19. And what is the unit? What were you asked? You were given a distance of 95 meters and 171 meters, right? In equal number of minutes. So this is the answer, which is meters per minute. Okay. So per minute, the greatest possible speed with which the girl can walk, should walk, so that the number of, to make the number of minutes equal, it is going to be 19 meters per minute. So you can write the answer here. The greatest possible speed will be 19 meters per minute. Okay. So always remember, whenever you are asked to find the greatest possible of or 2 or 3 numbers, then greatest possible of 2 or 3 numbers, then you'll have to determine the HCF, or the highest common factor. Now let's move on to the next question. The question is, find all the pairs of positive integers whose sum is 91 and HCF is 13. Show your work. So let the pairs of numbers, or let the two numbers be x and y. You are given the HCF of the two numbers, that is x and y, is going to be 13. That means 13 can divide x and 13 can also divide y. Okay, so x is nothing but 13 into something, right? It comes in the multiplication table of 13. 13 into something is giving you x. And for y also 13 multiplied, but that's why it's the HCF. 13 multiplied by some number is giving you y. So let this be P and let this be Q. Okay, wherein, let me write it as where P and Q are coprimes. Where P and Q are coprime. What do you mean by coprime? The numbers that have only 1 as a common factor. Okay, so x is the number, y is another number, and P and Q are coprimes. So this is the first thing. Okay, now what else are you given? You're also given for those positive integers, the sum is going to be 91. So you are given x plus y is equal to 91. This is also given in the question. Okay, now let's substitute x as 13p plus 13q equal to 91. So p plus q equal to, take 13 common out. So it will be 91 divided by 13. So 13 into 7 is 91. Okay, so the sum, that is the sum of these coprimes, right? P and q is going to be 7. Let us see all the possible values of numbers that P and Q would match in order to have a sum of 1 and in order to have a sum of 7. So all the possible pairs, okay, possible values of P and Q. So all the possible values of P and Q such that P plus Q should be 7 are, first of all, it's 1 and 6, and then you have 2 and 5, you have 3 and 4. Only these are the pairs of possible, wherein 1 and 6 are coprimes, 2 and 5 are also coprimes, 3 and 4 are also coprime numbers. Now, considering the value of P and Q which are coprimes, let us calculate what would be all the possible x values when you have P as 1 and Q as 6, when you have P as 2 and Q as 5, when you have P as 3 and Q as 4. Let's calculate that. So all the possible values of x and y are 13 multiplied by 1 and 13 multiplied by 6. 13 multiplied by 2 and 13 multiplied by 5. 13 multiplied by 3 and 13 multiplied by 4. These are the possible, which implies 13 and then 13 multiplied by 6. So you have 78. The other pairs of x and y that are possible are 26 and 65. And the last one is 39 and you have 12, 152. So these are the possible pairs. How many pairs you are not asked how many pairs? You are asked to find all the pairs of positive integers. So this is your answer. Okay. Please pause the video once and try to do it yourself. Okay. So you have to find the pairs of positive integers whose sum is given and HCF is given. Always remember, whenever you are given HCF, okay, always HCF can divide x. Okay. The HCF is divisible by both x and y, right? So this is the main essence of it. So you can write it off the form wherein the HCF multiplied by some number p is equal to your x, and 13 multiplied by some number is giving you y, where p and q are coprime. Okay, so even with respect to P and Q that you are getting, these numbers are actually coprime. So suppose if you are asked some other question wherein you are getting more pair, but the two numbers are not coprime, you should not be considering it. It is only a pair of numbers that are coprime to each other that should be considered. Right? Okay, so these are the possible values of x and y. So I hope it was clear. So this is your final answer. Now let's move on to the next question. Prove that 4 minus root 5 is an irrational number. We will be using, you can pause the video and try it yourself. And a similar question was also explained in the previous video that was posted yesterday. So let me do it. So the method is called as the contradiction method. Okay, so we will assume that let 4 minus root 5 be rational. This is the assumption that we start with, which means you will write 4 minus root 5 is equal to P by Q, where P and Q are integers and Q is not equal to 0. Right? Now the thing is, you have to isolate root 5 is irrational. So let's isolate root 5. So root 5 you can take it to one end, which will have root 5 equal to 4 minus P by Q. So here what I have done is, I have taken root 5 to RHS, isolated it, and P by Q I've brought it here, which becomes minus P by Q. Okay, so root 5 is equal to, take the LCM Q. So numerator you become 4Q minus P. Okay, so here 4Q, what was the assumption made? That P and Q are both integers. So here you have got 4 into Q. This is an integer. P is also an integer. Integer minus integer is also an integer divided by integer. So integer over integer is a rational number. So this is rational. And root 5 is irrational. And irrational cannot be equal to rational. So you have to write the statement that this contradicts. This makes our assumption wrong. This makes our assumption wrong. Therefore, what we had assumed initially, that is 4 minus root 5. Therefore, 4 minus root 5 is an irrational number. Is an irrational number. Hence proved. Hence proved. Do not skip any of these steps. Make sure all of these are written. You should also be including what is P and Q. They are both integers and Q is not equal to 0. All these details are very much needed in a question wherein you have to prove irrationality. Okay. So hope you understood. Please pause the video and do solve it. These questions are very, very important. Let's move on to the next question. Show that 5 plus 2 root 7 is irrational, given that root 7 is irrational. A very similar way of doing it, let us do. Again, you will be using the method which is called the contradiction method. So, let 5 plus 2 root 7, let it be rational. So, I can write 5 plus 2 root 7 is equal to P by Q, where P and Q are both integers and Q is not equal to 0. Let us isolate the term that contains the irrational part. So, the next step, 2 root 7 equal to P over Q minus 5. So, take the LCM Q, numerator becomes P minus 5Q. So, here you have 2 root 7. So, root 7 equal to, take 2 to the denominator in the RHS part. So, you will have P minus 5Q divided by 2Q. Okay, so root 7 is isolated because root 7 is already mentioned. You are given that root 7 is irrational. So, you are isolating the irrational part. So, again here you have root 7 is irrational. And on the right hand side you get integer minus integer divided by integer, which is nothing but all rational. Okay, so this is rational. And irrational cannot be equal to rational. So you will write a statement that this makes our assumption wrong. This makes our assumption wrong. What we had assumed initially, that is 5 plus 2 root 7. Therefore, 5 plus 2 root 7 appears to be is an irrational number. Is an irrational number, hence proved. Okay. So that's how you prove it. A very easy type. So more or less the last two questions that we just did were of the same type. Okay, it's just that the number is varying. All you have to do is just isolate the irrational part, keep it on the left hand side. Everything else you can take it to the right hand side, take the LCM and simplify, and make sure you are explicitly showing that left side is irrational, right side all is integers and they are rational. So this makes our assumption wrong. Therefore, the given number is an irrational number, hence proved. Okay. Hope you understood. It's very, very important question. Let's move on to the next. Find the least positive integer which on adding 1 is exactly divisible by 126 and 600. Now, what is the question asking? You have to find a number x which when added by 1 can get perfectly divided by 126 and 600. Now you tell me, is that number which can get divided by 126 and 600, can it be a smaller number or can it be a bigger number? It is definitely going to be a bigger number, because that big number has to be perfectly be divisible by 126 and 600. So if it is a bigger number, then what do we go for? We always take the LCM. Okay, so you are asked to find that value of that least positive integer which when added by 1 is perfectly divisible or is exactly divisible by 126 and 600. So this is equal to the LCM of 126 and 600. Okay, first let's calculate what is the LCM of 126 and 600 by doing the prime factorization. So I'm going to do it here. So 126, start with 2, 2 6 are 12 and 2 3s are 6. Again 3, 3 2s are 6, 3 1s are 3. Again 3, 3 7s are 21, 7 is a prime number. 600, start with 2, so 2 3s are 6, again 2, 150, again 2, 75, and then I would go with 3, so 3 2s are 6 and 3 5s are 15. Again, I'd go with 5, 5 5s are 25. Okay, so this is the prime factorization. So let me write the prime factorization. 126 equal to 2 multiplied by 3 square multiplied by 7. And 600 can be written as 2 cube multiplied by 3 multiplied by 5 square. So in the 126, in the factorization of 126, I don't have a 5. So I'm going to write 5 to the power 0. In the prime factorization of 600, I do not have a 7. So I'll write 7 to the power 0. Okay. So now for what I have to calculate is the LCM. And for LCM, I will be taking the highest power. Highest power of all the factors. Of all factors. Okay, so for 2 prime factor, for 2 as a prime factor, look at the powers of 2, which is the highest power. It is 2 to the power 3. So 2 cube. For 3, the highest power is 3 square. For 5, the highest power is 5 square. And for 7, it is 7. Right? So for 7, you have 7 to the power 1, 7 to the power 0. Take the highest power. So it's 7. So what is 2 cube? 2 cube is 8. Multiplied by 9, multiplied by 25, multiplied by 7. So 8 into 25, it is 200. Multiplied by 9 into 7 is 63. So you have 3 2s are 6, 2 3s are 6, and 2 6 are 12, and the 2 zeros. So 12,600 is the least positive integer which is exactly divisible by 126 and 600. Okay, but you are not asked the least positive integer which is divisible by the two numbers. You have to find that number which when added by 1 will be giving you a number which is 12,600. So x is nothing but the value that you just got, that is 12,600 minus 1. So you'll be getting 12,599. So 12,599 is the least positive integer which when added by 1, okay, will be giving you a number which is exactly divisible by both 126 and 600. Okay, so the number that you need, that you are asked, is 12,599. Hope you understood. The last question. So hope you understood. All these 5 questions are very, very important questions. So make sure you pause the video and solve it yourself. And if you are finding my videos helpful, and if you'd like to continue doing math with me, please do like the video and do comment if you're finding it helpful. See you all in the next video tomorrow. Thank you so much and happy learning.